So, hello, dear students. Good afternoon to one and all. So, can you just let me know whether am I audible and visible to all of you? Yes. Thank you, Ganesh. Thank you so much. What about the others? Is my screen visible to all of you? Yes. Yes. Thank you, Sumati. Thank you so much. Okay. So, good afternoon once again. And today is our first class, right? So, as I was telling yesterday, today we are going to see a new topic called General Organic Chemistry, which is your very basic lesson for organic chemistry. Okay. So, coming to the introduction of it, so organic compounds are vital for sustaining life on Earth, right? So, when you see the DNA, you can see the compounds present in it, which are nothing but your organic compounds, which are your nitrogenous bases like adenine, thymine, cytosine, guanine in case of DNA, and uracil in case of RNA, so etc. So all these compounds are organic compounds, so which are very vital for sustaining the life. So these are the structures of all the four nitrogenous bases you can see, and you can see the nitrogen, oxygen, hydrogen, carbon making the molecules, okay, organic molecules. And in fuels like petrol, we have organic compound, which is octane, which is basically a hydrocarbon. So octane is the compound which is present in petrol, okay, and it is a hydrogen and carbon containing system, which is your hydrocarbon. Got it? And in polymers also we are using like PVC pipe, polyvinyl chloride pipe, which we are using in our homes. So it is also an organic compound only. So you can see the structure here. So it is a polymer, polyvinyl chloride, which contains chlorine, carbon, and hydrogen in it. Okay. And in dyes industries, so for making dyes also, they are using the organic compounds only. So you can see the organic compound, which consists of two rings in it, and it is a crystal violet structure, which is present in the dyes. Okay. And in medicinal industries also, like in case of aspirin, if we take aspirin as an example, so you can see the structure of aspirin in it, which is an organic compound. Okay. Which is an organic compound. So basically, in all the fields, we are using this organic compound in our day-to-day life from morning till night. Got it? And coming to the synthesis of organic compounds, which is a very basic or which is also an introduction to organic compound. So you can see a scientist picture on the screen, and his name is Jacob Berzelius. Okay. So this scientist, what he did, he proposed that vital force theory in his period. And he told that vital force was responsible for the formation of organic compounds. What is vital force? Which is something beyond our strength, okay? Vital force, some supernatural power that is called as vital force. So he told that vital force is responsible for the formation of all these organic compounds on the earth. But later on, Euler scientist came. So his full name is Friedrich Euler. So later on, this Friedrich Euler, he came and he synthesized an organic compound in his lab. And the name of that organic compound is urea. Okay. And he prepared this urea from an inorganic compound which is called as ammonium cyanate. So you can see the structure of ammonium cyanate. It is NH4 CNO. It is actually NH4 plus and CNO minus. Okay. So he took this inorganic compound of ammonium cyanate and he heated this compound and he got an organic compound which is called as urea of formula NH2 C double bond O. It will be actually C double bond O NH2 NH2 NH2. Okay, this is your urea. But it is an organic compound. So since this Friedrich Wöhler prepared an organic compound from an inorganic compound in his lab, he he told that vital force is not responsible, or some sort supernatural power is not responsible for the formation of organic compounds. So I can also make organic compound which is otherwise called as naturally occurring compound in my lab. So he was basically an atheist, I think. So that's why he would have told. Okay, so he can able to prepare the naturally occurring compound in his lab from the chemical which he had in his lab. Okay, so he came secondly, and thirdly, one person came. His name is Hermann Kohl. So this Kohl scientist, he synthesized acetic acid in his lab. He also synthesized acetic acid. So formula is CH3COOH. Okay, it is also an organic compound which is made up of carbon, and he synthesized this particular compound in his lab. And fourthly, Berthelot, Marcelin Berthelot scientist came and he also synthesized an organic compound which is called as methane. CH4 methane, you all would be knowing, right? So he synthesized this methane in his lab. So you can see all these compounds contains hydrogen in it and carbon in it. So carbon is the main source, you can see, or the carbon is the backbone of all the organic compounds which was synthesized by all the scientists in their labs. Okay. So organic compounds contains carbon. Why? Why do organic means natural, and compounds you all know. So why the organic compounds mostly contains carbon, and what is the reason behind it? Why not the other elements? So we have 118 elements in our periodic table, right? But why specifically carbon? What do you think, students? Can anyone let me know the reason for this? Can anyone let me know the reason for this? So why carbon is used in the organic compounds? Any idea? Do any of you have any idea here to answer for this question? If you're having any answer, you can put it in the chat box. We will discuss. None of you have any idea? You might have studied the answer for this question in your 10th class itself. You might have studied the answer for this question. Okay. Okay. I'll discuss. So in today's class, we are going to discuss that only. Okay. So the introduction, representation, classification, and nomenclature part, we are going to see today. Got it? And coming to, they are produced by living organisms. Carbon is produced by living organism. Carbon is produced by living organism, my dear. Okay, let's discuss. Okay, so all living organisms based on, yeah, that's what I'm asking. Why all living organisms are based on carbon? Have the ability. Someone was telling something. What it is? Just a second. It have the ability to form stable bonds. Have the ability to form stable bond. Yeah, you are coming closer to the answer. It's half right. Okay. I appreciate your efforts, students. Good. let's discuss. Let's discuss this in detail. Okay. So, okay. So coming to the introduction, each carbon atom can form bonds with up to 4 other atoms. Very good, very good. Which is called as tetravalency. Yes. Yes, Anusha. Yes, yes. So both of you are right. The first answer is because of tetravalency. Yeah. So all organic compounds are numerous in number due to high catenation, high carbon-carbon bond dissociation energy, versatile nature of carbon. Yes. Okay. We'll discuss. Carbon tetravalency and carbon exhibiting bond multiplicity. So these 4 are the reasons to that question. Okay. So the main 2 reasons are the catenation. First reason is catenation and the second reason is tetravalency. So what is meant by catenation? What is meant by catenation? So the first point says that it is because of the high catenation ability of the carbon. So what it is? The ability to form chain of bond with itself and with the other atom is called as catenation. Ability of the carbon atom to form long chains or rings is known as catenation. So this carbon is having this catenation property. The element with the highest catenation ability is carbon. So carbon can able to form bond with another carbon. Also, it can form the bond with some other heteroatoms also, like hydrogen, oxygen, and sulfur, phosphorus, etc. Okay. So carbon can form a chain of bond with itself, or it can form the ring. So this particular property is called as catenation, and this particular property is very high in case of carbon. So that is the first reason. Okay. The second reason they are what they are telling is it is due to the high carbon-carbon bond dissociation energy, which one of you would have told this, no? It is stable. Carbon-carbon bond is stable. Yes, that particular bond is stable because it is the carbon-carbon bond is very strong. So the energy required to break the bond is very, very high. So that particular energy which is required to break the bond is called as bond dissociation energy. Okay. So why the energy is very high? Because the bond is stable. You cannot disturb a very stable person so easily, right? So it is that with this case also, and the energy is very high. And the third reason is tetravalency, which I was telling. The first main reason is catenation, and the second main reason is tetravalency. So carbon valence electron is 4. It can form 4 bonds. So what does it do? It will always share its electrons. It will always share its electrons. I'll discuss about this tetravalency in the next slide for you. So the ability of the carbon atom to form 4 bonds is known as tetravalency. So carbon is able to form 4 bonds because it has 4 valence electrons in it, right? And to exhibit the tetravalency, carbon forms all 4 single bond, all 4 single bond. So it can form 4 single bond like it is forming with in case of methane, and it can form 2 double bond. 2 double bond. It can form 2 double bond like this. In case of carbon dioxide, we have no. So 2 double bond. This is 1 double bond, and this is the another double. And 1 double bond and 2 single bond. So 1 double bond. In case of C2H4, all these molecules I will discuss with you in the upcoming slides. Okay. So you can see around this particular carbon, we have 1 double bond and 2 single bond, right? So, and the fourth point is 1 triple bond and 1 single bond. So where you can find this 1 triple bond in case of C2H2 molecule, around this carbon you see there is 1 triple bond and 1 single bond. Got it? So to fulfill or to exhibit the tetravalency, carbon is doing all such combinations. Okay. Around each carbon you will have 4 bond. That is a concept. Around each carbon you will have 4 bond. So by doing like this only, carbon is exhibiting the tetravalency. Got it? And the ground state electronic configuration of carbon is 1s2, 2s2, 2p2. We all know because the atomic number of carbon is, what is the atomic number of carbon, students? What is the atomic number of carbon? Yes, very good, Rashmi. Very good, Sumati. Good. So the atomic number of carbon is 6. So you all would be studied in the structure of an atom lesson. Yes, yes, Bharat. Good. So in structure of an atom lesson, you might have come across this shell concept, K shell, L shell. So the number of electrons that can be accommodated in the K shell is 2, and in case of L shell is 8. But since we are having only 6 electrons in carbon, so 2 was occupied by the K shell and only remaining 4 are there. Those 4 electrons will be there in the L shell. So in the outermost shell, you can see 4 electrons, which is the second shell. We have 4 electrons, and carbon is forming 4 bonds because of its 4 valence electrons. Got it? So this is the thing. And carbon is able to form multiple bonds also. So it is forming single bond, and it is forming double bond here, and it is forming triple bond. So it is forming double, single, and triple. It cannot form quadruple bond. It cannot form quadruple bond. Okay, carbon, quadruple, carbon, this kind of system is not possible. You can ask, ma'am, why carbon quadruple bond is not possible? Because we have only 3 axes, right? We have only 3 axes, X axis, Y axis, and Z axis. So this is Z. And there are only 3 p orbitals. So the last electron enters into the 2p orbital for carbon, right? So we have only 3 p orbital. One is px, and the other one is py, and the third one is pz. Okay. So we don't have 4th axis. So the electrons which is present in the orbital, they cannot come and overlap with the atom to form the 4th bond. Okay, that's why carbon quadruple bond with the other carbon or some other atom is not possible. Clear? Yes. So I hope this part is clear to all of you. If you're having any doubt, you can let me know in the chat box, or if it is clear to you, just type yes in the chat box so that I can understand that the concept is clear to you. Yes, thank you. Thank you so much, students, for your response. So what are the 2 main reasons? Catenation and tetravalency. Thank you so much to all of you for your response. Yes, tetravalency. So you should not forget these 2. Okay. I'll move on to the next topic. Next topic in the sense you are going to see a tabular column, which is very important for your exam, which consists of hybridization, bond length, shape, and bond angle. So, coming to first, alkanes, there are 3 different types of compounds, hydrocarbons we have. One is alkane, the other one is alkene, and the third one is alkane. So, in case of alkane, the hybridization of the carbon is sp3. Okay, and the carbon-carbon bond length in case of that particular alkane containing system is 1.54 angstrom. Okay, angstrom. And the example I will show you. And the shape and the bond angle is tetrahedral and 109 degree, 28 minutes. In case of alkene, the hybridization is sp2 and carbon-carbon bond length is 1.34 angstrom and the shape is trigonal planar with 120 degree. Coming to third one, alkyne sp 1.20 angstrom and it is linear in shape with 180 degree bond angle. Okay, you can see the examples given to you. So here, the name of this particular first compound is methane, right? If a carbon is having only single bond around it, or if a carbon is having 4 single bond around it, then the hybridization of that particular carbon is sp3. Okay. So one more example I'll give you for this alkane, which is C2H6, in which you can find the carbon-carbon bond length. Okay. So carbon is bonded with the another carbon, and each carbon is bonded with 3 hydrogen. So the name of this molecule is ethane, and this is the structure. So you can see the hybridization of this carbon is sp3 because it is having 4 single bond around it, right? And the carbon-carbon bond length is 1.54 angstrom. Got it? In terms of meter, 1 angstrom is equal to 10 power 10 power minus 10 meter. Okay, this is the bond length. And you can see in alkene, so alkenes are having sp2 hybridized. So these two carbons are sp2 hybridized carbons. And around each carbon, there are 2 hydrogen and 1 carbon. So if I connect these 3 atoms, I'll get trigonal planar geometry, right? So here in case of alkane, the geometry is tetrahedral. So tetrahedral means that particular system will have 4 faces. That's why it is called as tetrahedral. And the bond angle, this particular bond angle is 109 degree 28 minutes. In case of alkene, it is trigonal planar, like a triangle you are having. And the bond angle here in each case is 120 degree. This is like a triangle, right? So there are 3 120 degree present around each carbon. And coming to alkyne, you can see there is one triple bond. If you find any triple bond around the carbon, then you should write the hybridization as sp. And each carbon, you can see there are 2 atoms attached to it with 180 degree bond angle, which is linear in shape. Got it? This particular tabular column is very, very important for the NEET and JEE exam. Okay? You should not forget. Single bond sp3, double bond sp2, triple bond sp. And the bond angle 109 degree, then 120, then 180. The bond angle keeps on increasing. And the bond length, you can see it decreases. Bond angle increases, bond length decreases from 1.54 till 1.20. All these bond length values you have to memorize. These 3 bond values you have to memorize. Okay? Bond length and bond angle you have to memorize. There is no other option. Okay, you can memorize. You can do it. So do you have any doubt here in this tabular column? Shall I move on to the next slide? Do any of you have any doubt here? Okay. Okay, Valli and Smriti. I'll move on to the next one. So that is a question for all of you. Write the state of hybridization of carbon in the following compounds and the shapes of each molecule. So what you are going to find out? Hybridization and the shape you are going to find out for the following molecules. So 3 molecules are given to you. So let's do one by one. Let's take the first compound. It is H2C double bond O. So what you have to do? You have to find out the hybridization and the shape. Did anyone got the answer for the first question? The hybridization of the first carbon. Very good. Very good, Sumati. It is sp2. Yes. It is sp2. Because it is double bonded system, right? Yes, Chandana. So H, C double bond O, H. Yes, Rashmi. It is HC double bond O, H. Since it is doubly bonded with the other atom, oxygen, it is sp2. And the shape is trigonal planar. What about CH3F? Yes, trigonal planar. And what about CH3F? CH3F. What is the hybridization of the carbon in CH3F? Very good. sp3. sp3 because it has 4 bonds around it. Good. It is sp3. And what about the shape? I can see all of you giving the answer so easily and so quickly. Very good. You're all doing very great. So what is the geometry? That is, what is the shape? It is tetrahedral. Yes, it is tetrahedral. It is tetrahedral. And what about the third compound? Hybridization of the third compound? Very good. It is sp and linear. So easy, right? So if you are getting question from this part, you can score +4 mark very easily. Good, good. Good to all of you. Good. Great. So let's move on to the next concept. Okay. Representation of organic compounds. Representation. How to represent the organic compound. So there are 3 representations. The structural formula can be represented using 3 ways. The first way is called as complete structural formula representation. Second is condensed structural formula. Third is bond line structural formula. So how many types? Complete structure, condensed structure, bond-length structure. There are 3 types. Let's discuss one by one. All these are very easy only. So coming to the complete structural formula, you can see an example shown to you on the screen, which is ethane. So in case of ethane, the formula is C2H6, right? The formula is C2H6. In case of complete representation, you have to write all the carbon-carbon bond and all the carbon-hydrogen bond in the molecule. Got it? All the bonds has to be shown in your structure. If you're showing all the bonds in a particular structure, then it is called as complete structure. One more example is there. Ethene. What is the formula for ethene? It is C2H4, right? It is an alkene. C2H4. So all the carbon double bond and carbon hydrogen single bonds are shown. In case of ethane, triple bond and single bond is there. And in case of, what is the name of this molecule? CH3OH. It is methanol, right? So you have to write all the carbon oxygen, carbon hydrogen, oxygen hydrogen bond. Okay. So this is methanol. This structure is called as complete structure. Clear? Then I'll go for the condensed structure. So what is condensed? This is the complete structure of ethane. And if you condense this, you will get CH3 like this. So what is the difference between complete and condensed structure? In complete structure, all the bonds are shown. In condensed structure, only the formula is written. No carbon-carbon or carbon-hydrogen or some other atom bonds are shown. Okay. If this is the case, it is condensed. It is condensed. And you see the ethene, CH2 double bond, CH2. So carbon-carbon single bond, carbon-hydrogen single bond should not be shown. But carbon double bond or triple bond, so multiple bonds have to be shown in the condensed formula. So that's why they have written the double bond there. And in case of C2H2, ethane, you see, in case of ethane, carbon-carbon triple bond is shown, but carbon-hydrogen bond is not shown. So this is the condensed formula for ethane. And what is the fourth molecule we have seen? It is methanol, right? So all the bonds, how many bonds are there in methanol? There are 5 bonds in methanol. But you see, just in condensed, they are writing the formula CH3OH. CH3OH. Got it? So this is about the condensed. And you can still condense a long chain system. So how to do it? I'll give you an example. So this is an octane molecule. Octane means the system consists of 8 carbons. 8 carbon containing alkane is called as octane. Okay. And this is the condensed structure. But you can still further condense this particular structure. So how to condense further? Any idea? How can you still minimize the formula? How many CH2 groups are there? 1, 2, 3, 4, 5, 6, right? So I can write CH3, the left end CH3 is written here, and the right end CH3 is written here, and the in between 6 CH2 are written in curved bracket. And they have written 6 to it. Got it? So this is the C6H12. No. C6H12. C6H12. No, you cannot write in that way. You can write CH2 6 times. CH2 6 times. Like this you can write. Okay. So this is the correct way of representation. But anyway, good. Good. Students, clear up to condensed formula? Shall I move on to the bond length structure? Let's move on to the bond length structure. Okay. So in bond length structure, carbon and hydrogen are not shown. And the lines representing the carbon-carbon bonds are drawn in zigzag fashion. They are drawn in zigzag fashion. Let's see some examples. So 3-methyl octane is the example taken here. And it can be represented in various forms like, so this is the, what can I say? This is the condensed form of 3-methyl octane. Why it is called as 3-methyl-octane? Let me number the carbon. 1, 2, 3, 4, 5, 6, 7, 8. So in the third position, CH3 group, which is called as methyl group, is attached. That's why it is called as 3-methyl-octane. Don't worry about the nomenclature. We are going to discuss the nomenclature maybe tomorrow or today if time permits. Okay, I'll teach you. So this condensed 3-methyl-octane can be written like this. This is also kind of condensed or complete structure. But instead of writing the CH3, CH2 and all, you can write the zigzag lines like this. So this is the bond line structure. This is your bond line structure where all the edges are occupied by carbon. All the edges are occupied by carbon and each carbon should have 4 bonds around it, right? So if I take this first carbon, it is having only 1 bond. So the remaining 3 are hydrogens. The remaining 3 are hydrogens. And take this carbon, it is having only 2 bonds around it. The remaining 2 are hydrogen. And what about this carbon? It is having 3 bonds connected to it. Na? So it is having only 1 hydrogen. Clear? Here, this carbon, it is having only 1 bond around it. So the 3 are hydrogen. So, like this only, it is understood by all the people from the bond line structural representation of a compound. Got it? The only atoms specifically written are oxygen, chlorine, nitrogen, etc. Except carbon and hydrogen, if you are having any other heteroatom means different atom, which other than carbon and hydrogen. Okay, in your molecular formula, you have to write that particular atom in your compound. Let's see an example. Let me take 2-bromobutane. So what is the formula? Condensed formula for 2-bromobutane. This is the formula. 1, 2, 3 and 4. So to the second carbon, bromine is attached. I don't have to represent the carbon and hydrogen, but what I have to do? I have to write the bromine in the structure. So how to write? Write the bromine. This is first carbon, second carbon, third carbon and fourth carbon. And to the second carbon, bromine is attached. Clear? If you are having, let me take propanol. Propanol formulas CH3, CH2, CH2OH. This is the formula for propanol. This is called as propan-1-ol. Okay. Now, how to write the bond line structure for this particular structure? So, oxygen is present there. So, what I have to do? I have to locate the oxygen, right? If something is attached with oxygen, you have to write that also. OH is attached. So, first carbon, second carbon, third carbon, and to the third carbon, OH is attached. Like this, you have to represent all the heteroatoms like oxygen, chlorine, bromine, nitrogen, phosphorus, sulfur, etc. So this is the bond line structure of propanol. These 3 are the carbon atoms. Clear? Clear for all of you? So in the complete structure, what we are doing? We are representing all the carbon, single, double, and triple bond as well as hydrogen bonds. In case of condensed, we are representing only the carbon-carbon multiple bonds. In case of bond line, we are not mentioning the carbon and hydrogen, and other than these 2, all others are represented in the structure using zigzag manner. Okay, fine. Now let's go with the cyclic compounds. Bond line structure for cyclic compounds. Cyclopropane. Propane means 3 carbon containing alkane. If it is in the cyclic manner, it is called as cyclopropane. Now, how to write this compound in the bond line representation? You have to write like a triangle. This is called as triangle in maths, no? But it is called a cyclopropane in chemistry. Okay. And for cyclopentane, how to draw? Like a pentagon, you have to draw. And for chlorocyclohexane, you see, there is a chlorine atom attached in the ring. So what I have to do? I have to write the cyclohexane ring first, then I have to attach a chlorine atom in it. This is the cyclic structure of cyclic bond line structure of chlorocyclohexane. Clear for all? Fine. Now coming to the three-dimensional representation of organic molecule. Yes. Thank you, Bhavana. Thank you. Thank you. Coming to three-dimensional representation of organic molecules. The 3D structure of organic molecules can be represented on paper by using certain conventions. So what are those conventions? So methane is taken as an example to understand this. And you can see there are 4 bonds around each carbon, around the particular carbon, right? So 2 are represented with a normal line, So these 2 bonds are in the plane of paper, Now we all are listening from your mobile or laptop, right? So your laptop is the plane. These 2 hydrogens are present on your plane. Got it? And coming to the third bond, and the name of this particular broken wedge is called as dashed wedge. Dashed wedge is otherwise called as broken wedge. Okay. And this particular hydrogen atom is away from you. The broken wedge or the dashed wedge represents that the atom which is attached to it is away from you. Means it is away from your laptop or below your laptop or mobile. Okay. Then coming to the fourth bond, which is called as solid wedge. If you write like this, and if you color it, it is called as solid wedge. And this represents that the particular atom is towards you. It is towards you. That hydrogen is coming towards you. Okay. So 2 are on the plane, 1 is below the plane, and the other one is above the plane. This is a 3-dimensional representation of a particular molecule in a 2D axis. Got it? So what is the structure we are getting from this molecule? What is the structure of this? What is the shape of this molecule? And what is the hybridization of the carbon? What is the hybridization of this carbon? Very good. It is sp3. And what is the shape? It is tetrahedral. Very good. It is tetrahedral. Right? Very good. Very good. So see, we are getting a tetrahedral. Tetrahedral will be like this. So there is one hydrogen above, and this particular is on the plane, and this is this is below the plane, and this is above the plane. So you will get tetrahedral kind of structure. Okay. Fine. Like a fan. For fan, all the wings are on the same plane only, no? Like fan, all the wings are on the same plane. It is not above or below. So how can I express? Just a second, okay? So I have a pen. So this is the carbon. So you all can see, right? This is the carbon atom. And this is the hydrogen part, and this is the hydrogen part. Okay. Now these 2 hydrogens are on the plane. One is above the plane. One is, you see, this is the plane. This is the plane. One is above the plane, and the other one is below the plane. The other one is below the plane. Now you can see, right? You can see this tetrahedral structure, right? So all the 3 atoms which are here, they are not on the plane. They are not on the plane. If all the 3 atoms are on the plane, then you can say that the structure is similar to fan. They are not like this. They are bended, no? They are bended like this, no? So what is this? This is tetrahedral. Got it? So you can see the structure. You can just surf it in the net. You can understand it better. Yes. Okay, let's go with the next topic. Classification of organic compound. So we have studied the introduction part, and then we have studied the structural representation. There are 3 structural representation: complete, condensed, and bond line. And 3-dimensional representation also we have seen now. And coming to the next topic, it is classification. So organic compounds are classified into 2 two. So one is acyclic or open chain compounds. The other one is cyclic or closed chain compounds. Okay. And cyclic is again classified into two: homocyclic or carbocyclic and heterocyclic compound. Homocyclic and heterocyclic. So what is meant by homo? Homo means same. So the cycle is formed by the same atom, like cyclopropane, cyclopentane, which we have seen now. So all the atoms which has formed this particular ring, they are same. All are carbon. Then it is homo. If it is hetero, one of the atom is different. So I'll discuss the examples for all these things with you in the next slide. But now I'll just make you to understand. Okay, this is a heteroatom. So this is a 5-membered cycle with 4 carbon and 1 oxygen. So on hetero, different atom is present, you know. Hetero means different. That's why it is called as heterocyclic. Okay. Then homocyclic is again classified into 2. One is alicyclic. It is not Y, it is I. One is alicyclic and the other one is aromatic. So what are aromatic? Aromatic compounds are again classified into benzenoid compounds and non-benzenoid compounds. Okay, this is the classification. I'll give examples for all these. You just take a screenshot of it. You can take the screenshot of it. The flowchart, you can take the screenshot. Taken? Thank you so much, Sumati. I'll move on. I'll move on to the examples. So what is the first classification? It is acyclic, right? Acyclic or open chain compounds. So what are acyclic? It consists of a straight chain or branched chain compounds, and they're also called as aliphatic compounds. You should not get confused with this alicyclic and aliphatic. Alicyclic is different, and this acyclic compounds are otherwise called as aliphatic compounds. Okay, so which are having a straight chain and a branched chain system. So this is ethane. You can see it is in a straight chain manner. Acetaldehyde, isobutane, acetic acid. So all these are having some straight chain manner or some branches. So in case of ethane, it is a straight chain. Carbon-carbon is bonded in a straight chain manner. And in case of isobutane, these 3 carbon atoms are in the straight chain and 1 is branched. Okay. And acetic acid and aldehyde, they are having some functional groups attached to it. So all these are acyclic or open chain compounds. Okay. Now coming to the closed chain. Alicyclic or closed chain. Alicyclic or closed chain. So acyclic or open chain system is called as aliphatic. Cyclic or closed chain system is called as alicyclic. Don't think that all the names are confusing. It will be clear. Okay, this alicyclic, it is only represented like this here. Okay. Yes. So homocyclic and heterocyclic we had. Now coming to homocyclic, as I have told you already, if all the atoms are same, which is forming the particular ring, then they are called as homocyclic. Cyclopropane, cyclohexane. So everything contain carbon atoms joined in the form of a ring. And in case of heterocyclic, you can see the compound which I gave you, which is called as tetrahydrofuran, in which all the among the 5 atoms, 4 are carbon and 1 is oxygen. And in case of thiophene, 4 are carbon and 1 is sulfur. So these are coming under heterocyclic compounds. So sometimes other, just a second. Sometimes atoms other than carbon also present in the ring. Okay. It need not only be the carbon atom. It can be any other also. So these are the examples of heterocyclic and homocyclic. And coming to aromatic classification, So it includes mainly benzene and benzene derivatives compounds. Okay. So it was classified into two, right? Benzenoid and non-benzenoid. So what are benzenoid? Benzene containing compounds are called as benzenoid. So what is benzene? What is the formula for benzene? Can anyone tell me the formula for benzene? Can anyone tell me the formula? Very good. It is C6H6, right? So 6 carbon atoms and 6 hydrogen atoms. Yes, good. Benzene. And aniline. What is the formula for aniline? Good, good, Bharat. What is the formula for aniline? Good. Tell me the formula for aniline. Give me. Yeah. Shama Valmiki, tell me. What is the formula for aniline? C5H5NH2. No, no, no. You have missed one carbon. Rashmi. Sumati, you are good. Correct. Good. C6H5NH2. Good. C6H5NH2 is aniline, but aniline also contains the benzene kind of phenyl ring, right? So it is called as benzenoid compound. And you can see naphthalene here. Naphthalene contains two benzene rings fused with each other. So it is also a benzenoid compound. And coming to non-benzenoid compound, so benzene is having 6 carbon atoms in it. So all the 6 carbon containing aromatic systems are called as benzenoid. If a system has 5 carbon or if a ring contains 7 carbon, but still it is aromatic, then it is called as non-benzenoid. So you can see here, this azulene compound is an aromatic compound. But you just count the number of atoms present in the ring. Let me take the first ring. How many atoms formed this ring? 1, 2, 3, 4, 5, 6, 7, right? It is a 7-membered ring. And here in this ring, how many atoms you are having? 1, 2, 3, 4, 5. It is a 5-membered ring. So it is called as what? Non-benzenoid. If you are having 6-membered ring like benzene, it is benzenoid. Other than 6, you have anything? Any other? It is non-benzenoid. So azulene is the first example and tropolone. Tropolone is your second example. So how many membered ring it is? 1, 2, 3, 4, 5, 6, 7. Again, it is a 7-membered ring, but it is aromatic. So it is a non-benzenoid compound. Clear for all? Or if you have any doubt? If you have any doubt, you can raise your hand and ask it. And I'll go for the last classification. Clear? Thank you. Thank you. So coming to the last classification, which is heterocyclic aromatic compound. I forgot to tell this while explaining the flow chart. This is the last classification under aromatic. Okay, heterocyclic aromatic. Heterocyclic, we know. One hetero different atom is forming the cycle. In addition to that, if the compound is aromatic in nature, it is called as heterocyclic aromatic. So don't worry about this aromaticity concept. So you can have a question in your mind. Why ma'am is telling certain compounds are aromatic and what is the criteria for a compound to be aromatic? Don't worry about it. I'll teach you the aromaticity rules. I'll teach you how to find out whether the particular molecule is aromatic or not. There are certain rules. There are 4 rules. And if a compound follows all those 4 rules, then that particular compound is called as aromatic compound. That I will teach you in the next lesson, okay? So don't worry about that. So now you see, this furan is an aromatic, heterocyclic aromatic compound. Since one hetero atom oxygen is present in that ring, it is heterocyclic aromatic. And here thiophene, heterocyclic aromatic. In pyridine, pyridine is looking like benzene, but instead of 1 carbon, you have to write 1 nitrogen. Got it? So it is pyridine heterocyclic aromatic. And all these compounds are classified on the basis of 2 things. One is on the basis of functional group and the other one is on the basis of the homologous group. One is on the basis of functional group and the other one is on the basis of families of homologous groups. Okay. So I have given you the examples of all the types of classifications which I have told you. Now we are going to see what is functional group. Can anyone tell me what is functional group? Definition for functional group in simple terms, or you can tell me what you know. What is a functional group? Don't give me the examples of functional group, okay? Tell me what is functional group. What is a functional group? Any idea? Okay, no problem. Or a group of atoms within a molecule that has similar chemical properties whenever it appears in various compounds. Similar chemical properties is called as functional group. Okay. Group of atoms. A group of atoms responsible for the characteristic reaction of a particular. Very good. Rashmi is exactly correct. And which is responsible for the chemical property. Anusha and Sumati also, you are also correct only, but 90% is correct. Just responsible bonds that define the functions. Okay. So all of you are giving me the definition for functional group in your terms, which are also correct. Okay. Fine. Good. So I'll give my definition. Okay. The reactive part of the molecule is called as functional group. What is a functional group? The reactive part of the molecule. You can have a big molecule or you can have a small molecule, but the reaction occurs only in one center, right? So where does it occur? It occurs only in the center where functional group is present. The functional part of the molecule or the reactive part of the molecule is called as functional group. Okay, but we cannot write the same statement in exams, no? So there is a specific example given to you. Atom or group of atoms joined in a specific manner, which is responsible for a characteristic chemical properties of organic compounds is called as functional group. So why it is called as chemical properties? Chemical reaction occurs only in that particular center where the functional group is present. So the reactive part of the molecule is called as functional group. Good. So all of your answers are correct. And you can see a compound on your screen. What is the name of this compound? Do any of you know the name of this compound? It is called as phenol. The name of the compound is phenol. And you can see OH group attached to the phenol. OH group attached to the phenyl ring, which is called as hydroxyl group. So this OH is the functional group where the reaction occurs. And this compound is called as benzaldehyde. Okay. And CHO group is present. This is carbon, no? C double bond OH. CHO group is present, which is called as aldehyde. And aldehyde is the name of the functional group present here in this compound. And coming to the third compound, the name of this compound is carboxylic benzoic acid. And the functional group present in it is carboxylic acid, which of formula COOH. So these are the functional groups, some of the very important functional groups which you will be studying in your upcoming lessons. Okay. So whenever these particular compounds react with some other thing, the reaction occurs only in this OH and COH and the COOH part. Got it? Now coming to homologous series. So there were two things. One is functional group and the other one is homologous. So functional group I have discussed, and coming to homologous, a group or series of organic compounds, each containing a characteristic functional group, forms a homologous series. So it is a class of series or a group of series which contains the same functional group, but what is the difference? Let me tell you by giving an example. Let me take alcohols as a class of compound. Okay, alcohols contains OH group. One carbon containing alcohol is methanol and the formula is CH3OH. Two carbon containing alcohol is called as ethanol and this is propanol and this is butanol. Yes, very good, Rashmi. There is a difference between two compounds with CH2 units. So if I am going from the first compound to second compound, what is the difference? CH2 units is getting added, no? And if I am moving from second to third, from ethanol to propanol, and one more CH2 is added. And by the addition of this CH2 part, I am getting a class of compounds, a series of compounds which are called as homologous series. And coming to alkanes, methane, ethane, propane, butane. Okay, what is the difference again? Again, the CH2 is the difference. CH2 is the difference between the two molecules. So they are forming a class of compounds like alcohol, alkanes, alkanals, alkanones, alkanoic acids. Got it? So it is giving rise to a class of compounds. The members of this series are called as homologous. Okay. So let's solve one question for today's class and wind up the class. Okay. So just try to answer fast. How many sigma and pi bonds are present in each of the following molecules? How many sigma and pi bonds? So two compounds are given to you. You give me the answer for the compound A. How many sigma bond and pi bond is present in compound A? So to find out that, you have to draw the complete structure. You have to draw the complete structure. Complete structure means all the bonds should be represented in your structure. Then start calculating. If you're having only one bond, then it is considered as sigma. If you're having only one bond, it is sigma. If you're having two bonds, one is sigma, the other one is pi. If you're having three bonds, one is sigma, the remaining two are pi. This is the concept. Okay, so just calculate here. Here I'm having triple bond, so one is sigma, the remaining two are pi. The sigma, sigma, here one sigma, one pi, all these are sigma. So have you calculated how many sigma bonds are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 10 sigma and 3 pi bonds. 10 sigma and 3 pi bonds. So CC sigma is 4 and CH sigma is 6. So totally 10 sigma and 3 pi. What about the second compound? Second compound. Each carbon should contain 4 bonds around it. Okay. So according to that, you would draw the complete structure and find out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 sigma. And how many pi? 2 pi. Yes. 9 sigma, 3 plus 6. 9 sigma and 2 pi. Very good. Very good, students. Very good. So the next topic, that is the nomenclature part. This we can discuss in the next class. So you all go and study the introduction part and the structural representation part. Okay. And the functional groups and homologous series today. Okay. And solve the questions related to it from your workbook and come for tomorrow's class. And tomorrow we will discuss about the nomenclature, the common name and IUPAC name for all the organic compounds. Okay. So if you're having any doubt, you can ask me in the chat box now, or else you can go home and study. You can ask me tomorrow also. Okay. No doubt. Okay then. So I'll meet you all tomorrow. Thank you. Thank you so much, students, for listening to the class, and thank you. Take care. Bye-bye. Thank you. Thank you.